Hello everyone, thank you for joining me today. My name is Maciej Chmielarz. I'm a software development manager here at Amazon. I work at Amazon Development Center Poland in Gdańsk. And today I would like to guide you through some basic concepts related to building Alexa skills and also talk about the task that we prepared for you for innovation at Amazon Online Hackathon this year. So let's get started. And let me start with some context, context of how Alexa was created. So our vision for Alexa came from the computer from the Star Trek, a computer that is available everywhere, can answer any question, and can do that using natural voice. The idea of making this vision come true came from observing a few key trends. The first observation was related to the development in the field of machine learning. Machine learning algorithms prove to be really powerful, and if you feed them with big data, they are delivering incredible results. The second observation was the rise of cloud computing. When you talk to engineers, when you ask them, they actually imagine in not so distant future a world of infinite storage and infinite compute power, and all of that thanks to the cloud. The third observation was related to the way that people communicate. Our brains are wired for speech, and voice is the most natural way for us to communicate. So we brought machine learning, cloud computing, and voice together, and this is how Alexa was created. And if you look at it, and if you look on how people interacted with computers over last, let's say, 50 years, there is like a constant development in that. So we started with character mode, where we interacted with computers using text. Then came applications using graphical user interface, GUI, that we could interact with using this GUI. After that came web applications that we used in our browsers, followed by mobile applications that we use on our smartphones using touchscreens. And right now we see more and more application using so-called voice user interface, so VUI, and we believe that this is going to be like the next interface after all of those that I just mentioned. And how does it work? Well, Amazon Alexa is a service in the cloud, so it uses automatic speech recognition, natural language understanding, and text-to-speech speech synthesis to interact with customers, with users using voice. It is in the cloud, so it is always learning, getting smarter every day. And it's actually built out of two important frameworks that enable brands to connect to customers. So the first one is Alexa Voice Service, AVS, that allows developers to enable voice interactions on connected products. So if you develop a device that has a microphone, has a speaker, and has internet connection, you can use AVS API to connect this device to Amazon Alexa. On the other side, there is Alexa Skills Kit, ASK, which is a set of tools that let you teach Alexa new skills. Using Alexa Skills Kit, you can build VUI applications that your users can interact with to communicate with Alexa and to provide to provide input to your application, and you can also, and your application can provide feedback to the users. And what kind of skills we can have? Well, different types of skills. There are skills that are built by independent developers, published in Alexa Skill Store, but there are also skills published by big brands that are simply yet another way for their customers to interact with their services, with them. So, for example, you can imagine a skill published by a restaurant chain that lets their customers place orders. So, over the years, a lot of developers contributed to those skills. So, right now we have like over 100,000 skills, and this is also making Alexa like even more interesting. And we also observe a rapid growth in the number of skills, because when we launched Alexa in 2014, we launched with 13 skills. And as I said, right now we have after 6 years, we have like over 100,000 skills in the store, and the number is growing all the time. Okay, so let's talk about how those skills work. So, what is the technical architecture of an Alexa skill? So, Alexa skill consists of two basic building blocks, one of which is a voice user interface that you design in order for your customer, for your user to interact with your skill and provide input to your skill. And the other building block is the programming logic. So the logic that processes the input that user provides with this voice user interface, and processes it, reacts to it, and provides some response to the user. Speaking about a voice user interface, you design and develop it using our developer portal, developer.amazon.com. And speaking about the programming logic, this is the programming logic works on AWS, Amazon Web Services. So this is where all the heavy lifting and processing of the input actually happens. And in order to create an Alexa skill, you need to go through a few basic steps. And so the first two are the basic building blocks that I just mentioned a moment ago. So designing the voice user interface and writing code for the processing of the input that user provides. Besides of that, you also need to configure your skill. You need to test it to verify how it works, and eventually publish in the Alexa Skill Store. For this event, for the hackathon, we don't require you to publish the skill, so we also accept prototypes, proof of concepts that just show the idea that you want to present for the solution for the problem that you want to solve with your skill. However, you are also free to publish your skill after the event, because we are not claiming any copyrights to whatever you develop during the event. So you are free to polish and publish your skill afterwards. Okay, let's dive a bit deeper into how the Alexa skills work. So all of that, of course, starts with the user that is interacting with Alexa through devices. So in order to start the interaction, user has to use a wake word so that the device knows that the user speaks to Alexa and can pass the input from the user to the cloud. So when the wake word is detected, the device opens the microphone and records the information from the user and passes it to the cloud so it can be processed by this utterance provided by the user can be processed by speech recognition and natural language understanding. So this processing happens in Amazon Alexa in the cloud, and as a result of this processing, an intent is created. So a structure that contains all the information that your skill needs in order to do the processing, in order to process the input. And this intent is passed to your service. So your service gets the all the information from the user input that it needs, processes it, and prepares acts on it and prepares some response for the user. This response is fed back to the Alexa, to the cloud, where our text-to-speech service turns this response into speech, and this spoken response is streamed back to the user through the device. So as I mentioned, when the user is speaking with Alexa, such interaction starts with a wake word. It can be Alexa, but also other wake words are accepted. So this is like configurable. So the user says Alexa, and next the user has to say a verb that indicates that they want to invoke a skill. So, for example, then they can say, Alexa, open Restaurant Finder, where the Restaurant Finder is the invocation name, so the name of the skill that should be invoked, that should be used. There are also other words possible in order to start to invoke the skill. So the user can say, Alexa, start, launch, begin, resume, ask, or tell, and then the skill name, and all of that is going to work and is going to invoke the skill. So after that, after this invocation name, comes the utterance, so the actual content information from the user that is later put into the intent and processed by your skill. So, for example, the user can say, Alexa, ask Restaurant Finder to find places to eat in the morning. And Alexa will process that and will provide your skill with the key attributes of this utterance so that you can process that and prepare the answer. So, for example, in the case of those utterances that you could see in the previous slide, all of those are put into the recommendation intent that can later be processed and in order to provide the meaningful answer. And each utterance can contain also some attributes, can contain some arguments, like key values that are needed in order to process this utterance properly. Those are called slots, and when such a slot is available in the utterance, it is put into the intent as an attribute. So in this case, when we have like a utterance where the user is asking to recommend a restaurant within 4 miles, so for your skill, in order to process it properly, it needs to know what is the radius in which the user is looking for a restaurant. So this value of 4 is put into the intent, and you get it in a JSON format, and it can be parsed, and your skill can act upon that properly. And every utterance can have like more than one slot. It's not like there only one value can be provided. There can be multiple slots per utterance. So for example, if the user says, tell me about Italian food within 4 miles, your skill needs to understand not only that the user is looking for a restaurant in 4-mile radius, but also needs to understand what cuisine the user is looking for. So in this case, this intent is going to contain 2 attributes, distance and cuisine, with appropriate values that were provided by the user. So these are like very basics of how this how skills work, and you can try that out yourself, because we have a tutorial that you can follow. You can go to alexa.design/hello world, and there is like a guide that will guide you through the process of creating a very simple Alexa skill, so you can try that out. The things that I said, you can try them out yourself. And I would also like to mention some more complex example than what I said before, and I will use an example of a pet match skill for that. So this is a skill that matches pets to the requirements of the user. So the user provides some characteristic about the pet that they would like to have matched, and the skill matches those pets. So this is like a bit more complex use case with some more information to be provided. So for example, a user can say, I would like a dog for my family that's big and high energy. And that is going to be put into pet match intent with 4 slots. So the kind of pet, the use case for which this pet is needed, and the size of the pet, and the energy that this pet should have. And the skill pet match can process this kind of intent, and can also receive like system intents, like cancel intent, help intent, stop intent. And of course, you can define more than one intent for your skill as well. And in this case, as I said, we have like 4 slots in this intent. So user can say, I want a dog that's tiny, low energy for my family, or I want a dog that's large, high energy for my guard. So depending on what kind of pet they want, and those values for those slots are going to be put into the intent and passed to your skill, so it can make the appropriate match in this case. So in case of this kind of utterance that has only a few slots, so only a few pieces of information to be provided, you can do that in a single shot invocation. So there's one sentence that provides all the items that are needed for the skill in order to process them. However, it's not always the case. Sometimes you need more information, like 8, 9, or 10 slots. So in such a case, it's hard to expect that the user will be able to provide that in one breath, because before they finish the sentence, they may simply forget where they started and what were they saying. So it might be hard for Alexa to understand what what the user really needs. And this is obviously not good because this creates friction, and this can prevent the users from using your skill. But fortunately, there is a solution for this problem, and the solution is multi-turn dialogue. So the user can talk to Alexa, have a conversation with Alexa, providing like information one piece at a time. And I have an example here as well. So this is an example based on a skill of a name Outdoor Guru that provides some recommendations about outdoor activities depending on what the user wants to do. So in order to invoke the skill, the user can say, Alexa, start Outdoor Guru, or Alexa, ask Outdoor Guru about kayaking. And in this case, for example, when there is like this information about the activity provided in this invocation, the skill can react to that and ask follow-up questions like, okay, kayaking, but where to? Portland. Portland? Yes. When do you want to leave? Next Friday. Until when? The following Tuesday. What will you like to do? I will be golfing. Did I get all this right? So here comes the confirmation of all the items that Alexa collected over this communication, so that Alexa can make sure that she understood everything correctly, and when she passes this information to your skill, that it will create like a desired result. And when the user confirms, yes, this intent is created, is provided to your skill, and your skill can handle this. So your logic that you implemented can handle this and prepare the answer. Like, for example, I have 2 ideas for you, and provide those ideas to the user. So in this case, we have a few types of interactions in this whole dialogue. So there are questions asked by Alexa that are basically slot elicitation. So Alexa is trying to elicit information from the user, for example, asking where they want to go, or when they want to leave, etc. There is a question that is a slot confirmation. So basically, Alexa repeats what she heard and is waiting for the user to confirm that this was like the correct value. And at the end, as I mentioned, there is like a question that is the intention is to confirm the whole intent. So make sure that items collected through this dialogue are actually those that the user, the values are correct, and those that the user wanted to provide. And after the user confirms it, the whole intent can be passed for processing. So as you can see, this can be much easier for the user to provide when this is split into such chunks. So you need to remember that in case of such more complex use cases, the right way to go is to use such multi-turn dialogues, and there is an option for that. Okay, this is all that I wanted to say about building Alexa skills. You can learn a lot more from the material that is available on our website. So, as I said, there are tutorials and guides that will guide you through building some simple Alexa skills, and will also give some more complex examples. So you can refer to our website and try them out in order to prepare for your own development. I encourage you to do so. And right now, I would like to talk about the main theme of this hackathon, main theme of the task that we are putting in front of you, which is accessibility and inclusion. We decided to use this socially important topic because we are actually working on accessibility solutions ourselves. My team is in the text-to-speech business, in speech synthesis business, and this is TTS solutions are oftentimes used for accessibility purposes. My team is responsible, for example, for integration of the speech synthesis technology on Fire OS, which is our operating system that is used on our devices, like, for example, Fire tablets. And this speech synthesis technology that we deliver to those devices is used, for example, by VoiceView, which is accessibility screen reader that helps visually impaired customers interact with our devices. And I have a tablet with me, and I can actually show you how it works. So let me just invoke the VoiceView here.
VoiceView ready. VoiceView screen reader.
I suppose that you can hear that.
VoiceView screen reader. VoiceView is on. To disable. Home. But home. Shop Amazon. Row 1. Settings. Settings.
So basically when
to activate.
Visually impaired user interacts with a device using a screen reader, and they use gestures to navigate through the interface, and they get spoken feedback about the items on the screen. For example, right now I have settings opened, and if I swipe to the right, it will go to the next item and will simply read its name.
Display. Device options.
There are also options to get like more precise information, like, for example, word by word or letter by letter.
Window. Element. Sentence. Word. Character. Alexa.
And
double tap to activate.
And now
A. Alpha. L. Lima. E. Echo.
It basically reads the word letter by letter. So this is a solution that we support with our text-to-speech engine on our Fire OS devices. So this is something that is really important to us. So the cause of accessibility. Also, Alexa is a service that is very helpful for people with special needs. I remember a testimonial from a person suffering from multiple sclerosis that said that because the illness caused some motor impairments for that person, she was very happy with Alexa because she basically regained control over the music that is played in her home, because right now she can simply ask Alexa to play a certain song, and she does not need to operate any device using her hands. So that was a very, let's say, small but very important improvement for her, that she regained control over that. So Alexa has a great potential to help people with special needs as well. Our colleague Troy Larson uh, a few years ago developed a solution based on Alexa and Amazon Web Services to support his autistic son Calvin. The project was named Polexi, and there's like a very interesting video about this project that I believe is very inspiring and can inspire you to look for use cases that Alexa can support and that can support people with special needs, but not only with people with special needs, but also their allies, because we are looking for solutions like this as well. So solutions that support family, friends, co-workers, caregivers of people that have special needs as well. And as I mentioned, there's like a video about Polexi available, and I would like you to watch it. So because it's really, I believe it's really inspirational, and we are looking for such solutions during this hackathon, such ideas that would be similarly inspiring. So this is all from my side, and we will play the video about Polexi right now. So thank you very much for your attention, and good luck with the competition and your skills. Thank you very much.
My name is Troy Larson. I work for Amazon Web Services as a DevOps Cloud Architect, and I focus on automating solutions and building out code deployment. My son is named Calvin. He's 16 years old, and he has autism.
What's your name? My name is Calvin, yeah. And how old are you? Look at the camera. Look at the camera. How old are you?
You're 16 years old.
You're 16 years old. And what's your teacher's name?
Yes, Bauer.
Okay, so he can answer basic questions. But when it comes to spontaneous, that's when be cool.
As he is growing into adulthood over the next several years, the services may not be as abundant for him as we might need. And so how do we help him to transition to adulthood, potentially even to be able to live somewhat semi-independently without having to have constant physical supervision? He was diagnosed when he was 3 years old, and he's nonverbal, so he can speak some words, but he's not able to have a conversation. For Calvin, the challenges of living independently are primarily around his own personal care and safety. So things that we take for granted, like brushing your teeth and showering and going to the bathroom, those are things that Calvin won't do unless he's prompted. When he's at school or he's at home, we can tell him to do something and he'll follow through with that instruction. One of the challenges with autism is every child is different. There's things that they get and there's things that other ones don't get. And so you're always trying to find that one key to unlock that understanding. Verbal interaction has always been his key. So voice was the technology that we were waiting for to really build a tool that might be able to help with Calvin's communication. When Polly and Lex were announced, it was actually a system where we could actually build communication on the fly. So the first time I used the technology, I did not have Polexi yet, it was just playing with Polly. I had my laptop and we kind of hid around the corner of his bedroom.
Please push the
and
button.
I had Polly say, "Calvin, it's time to go potty. Let's take a break and go potty." And we waited a few seconds and all of a sudden his door opened and he walked out, quizzically looked at us like, what are you doing here?
What time is it? It's time to...
Brush your teeth.
And at that point, I knew, yes, this could be something that we could definitely leverage because he understands that voice. The idea behind Polexi is to build a system that is aware of a person's specific physical needs and is built around the ability to prompt them to give them that quality of life, that sense of confidence where they can function almost independently, and it's invisible, it's not intrusive.
Yeah,
Tell Plexi with Brian, tell Calvin, come downstairs.
There was a problem with the requested skills response.
Tell Plexi with Brian, tell Calvin, come downstairs.
Got it. Publishing message, come downstairs to Calvin at location Calvin's _ bedroom.
Please push the blue button. Good evening, Calvin. Do you want some pops? Come downstairs right now to the kitchen to get some pops. Good evening, Calvin. Do you want some pops? Come downstairs right now.
One of my concerns with this project was that we're trying to automate parenting with Calvin. And that's not the case. The idea here is to give him a sense of freedom in the same way that we all want that sense of freedom. We don't walk into our kids' bedrooms every 5 minutes, checking on them and telling them what to do. And the idea here is to give him that respect of privacy and keep his stress level down.
Okay, now brush your teeth.
It was cool because there was no physical person in the room. There was no face. There was no someone tapping him on the shoulder. It was an invisible voice that he responded to. And that's very chilling to think about, in that you're wanting to have a conversation with him all the time. And when you're able to find something that can communicate with him and that he can understand, your brain just starts wondering, how else can we use this?